at Hyderabad, both auto and farm division. So most of the case studies are from that only. This is the overview of Mahindra Group. We are having presence in 11 sectors, 150 plus companies, 100 plus countries. Particularly, we are today focusing on farm and automotive division. Perhaps we are the one and only who are manufacturing two-wheeler and 20-wheeler, both the things under auto and farm divisions. This is our global footprint. We are present in multiple countries. Our R&D centers are there in multiple countries and also manufacturing. This is our product portfolio at Hyderabad plant in Telangana specifically. So we have recently launched 2 new products in auto also and farm also. Both are our techno-savvy products. One is EV related commercial vehicle, and then our all new tech pack ready tractor, which are going to be which are launched at global platforms, and that will be having many new features introduced first time in the tractor industry. So these are different 7 models which are introduced through OJA that has been recently launched on 15th of August. Focusing on to our journey as a Mahindra and Auto Farm sector, this is our journey toward digitization. So we have started with our strategy and our program formation since 2016-17, and this is the way we have moved ahead. So we have focused on multiple themes like IoT, robotics, digital operations, which will be coming forward into this presentation. All this has been integrated in our own customized MES platform, which are called as Drona. So why technology? So these are the challenges which industry is facing nowadays. So increasing model complexity, improve competitiveness in the market. To survive in the market, we have to improve all these parameters. We have to go through this complexity of the models and yet maintain our margins. So for doing that, we have adopted the different approach. We have simplicity, customer centricity, process robustness, flexibility. These are we have adopted into our approach, and working on these initiatives, we have formed our case studies, which we are going to showcase with you. So these are the major themes: low cost automation, digitized operations, IoT, and new technologies. I will skip this slide because this is going to be covered in future. Okay. In low cost automation, we are going to present a few case studies. So this is our main drive, no fault forward. So whatever we are manufacturing on the particular station, that has to be first time right, and there should not be any fault going forward to the inspection. So based on that themes, we have showcased few of the case studies. This is our one of the case studies in which we have addressed near about 400 plus failure modes, and from those failure modes we have categorized them into 4 different buckets in our assembly operations, like torquing, part missing, wrong assembly, similar looking part. These are the areas which need to be addressed for covering major failures in the processes. So these areas we have addressed through basically we are having both legacy of operations. There are old plants which are running on the manual operation. So we have gone for the requirement-based, need-based digital solutions on those stages. So that we are focusing. So these are few of the examples which we have done at our plants. So for torque missing, there are legacy tools which are pneumatically operated. So this has been fitted with some electronic and IoT-based devices to control the torque and specification. To meet the requirements that we are addressing this with the first torque missing case study. The second is part missing, in which we are going for the multiple type of sensors, right from proximity sensors, inductive based sensors, laser sensors, steel vision sensors. So depending on the requirement, we are adopting this sensor technologies to detect the part missing part missing area. Then in wrong assembly, we are also, this is one of the case study in which we have used a laser based sensor so that we will know that the part orientation is right and there is no wrong assembly being made on the particular stage. Then similar looking parts for this, we have also used different vision technologies. So at the low cost area, we have used the color based sensing so that we will identify that the part is right or wrong, wrongly assembled. This is one of the video which will showcase you how we have modified the stage for no fault forward. This is a piston and ring assembly. After this assembly, this part has been checked for multiple parameters before going forward with different technologies, like from scanning, from vision sensing, sensor-based sensing. Once it passes through all these parameters, then only the part will go forward. So we are ensuring that whatever we are producing on the stage, at that stage only it will be addressed. So these are the benefits of it. 100% built-in quality, that is a focus area. This is one of the case study of spot missing concern, in which the operator actually do the welding job on the station, and many a times the operator misses the spot. So this particular case study is focusing on some small electronic devices which are fitted inside the controllers, and those are connected with the assembly fixture, so that unless and until the required spots has been taken, the assembly will not get dismantled from that particular fixture. So this is the basically case study. This is a small representation of the process. Once the operator will finish the entire spotting, then only the part will get disassembled from the stage. Then these are the weld spot counters. So many times, many assemblies have different models, and with respect to different model, these are different spot weld configurations. So with respect to that, it is a complex operation for operator to remember all these spots. So we have integrated this particular spot counter foci with different models, so that whenever the particular model get assembled on the fixture, that particular model spot counter will be activated, and unless and until operator weld those many spots, it will not get disassembled from the fixtures. This is to address the model complexity that is getting added into the portfolios. So once the required spot has been reached, then only the fixture will get declamped. So the benefits of this has, again, no fault forward, so 100% built-in quality. This is one of the case study for IoT. This particular case study, nowadays we are having a lot of technologies available inside the tools, where we can connect the tools with the softwares and we can have the data for the traceability. But this particular case study is focusing on the legacy tools, which we have modified for getting right specification, product and process specification, and then this data is getting logged into the software and it is represented on the dashboard. So this is with the very few thousands of amount we have done it inside our plant only. So this is basically a dashboard which represents different torquing status of the tools, and with respect to particular model number or particular tractor number, you can basically have this data available with you, so to know that the process has been done right. This is small video for that. In new technology, we are actually now focusing more on vision-based systems. Wherever the sensors will not work, so we are focusing to go for vision-based systems. And also at new production lines, we are also focusing to address critical stations with robots and cobots. So this is one of the example which we are working in Zairabad plant only. So this is cabin assembly line, so in which the electrical testing of different lights and different indicators are being done by the vision cameras. So this cabin is being tested by cameras, and the data has been stored into the softwares for future traceability. So with robots and cobots, we in Mahindra as entire AFS, we are having 500 plus robots, 50 plus cobot installed. So whatever new lines are getting installed, on which we are also focusing to go for critical operations like hemming, sealant, and then painting. For those things we are choosing the critical operations, and we are selective in our approach to go for the robotics and entire automation. This is one of the video of printing robots facility installed at Hyderabad. This is a similar application process done by cobot. So these are the initiatives, or I can say automations, which are helping us to make a first time right product and no fault forward. As I told you in my first slide, this is our MES platform. This is manufacturing execution system. This is customized, developed for our operations. We call it as a drona. So this we use for connecting our different operations together. Like in our company, we are having a different set of operation, right from sales side order till the dispatch. So to have the entire visibility of the processes and to swift decision making, and also to manage the operations digitally and also effectively, this platform has been developed. So many of the tools like process data, many of the plug data, as well as the operation data has been logged onto this platform, and from this we are having a visibility of entire process and what is going right or what is going wrong into the operations. So I will leave you with, this is my last slide I think, and I will leave you with small AV after this. So 2-3 minutes AV is there. It is self-explanatory, you can easily understand. Thank you. Thank you.
Thank you, Tushar. It's very heartening to see the automation right in our neighborhood, Zahirabad. I would urge members here, if there's any opportunity to visit the plant which M&M has been um, encouraging us to visit the plant every year. I've done that, and it's a great learning experience. And to see all the automation happening from our own Indian company, I think it fills my heart. Thank you, Tushar. We will have the Q&A at the end, the other two speakers completing their talk. We are allocating good amount of time because the subjects are very interesting. I'm sure there are many queries from the audience here. I request our next speaker, Mr. Karthik Chittapu, who is the Director, Customer Excellence from CAD-FEM, India, to take over.
First of all, thanks for inviting me for this conference, and it's my pleasure to give a small update on, what are the new technologies or digital engineering in terms of simulations. Okay, can you go to the first slide, please? Oh, I can go. Yeah. So I come from a company called CAD-FEM, and I think the name itself says much about digitalization, right? So it's the CAD, which is a virtual designing of yours, and there's a FEM, which is a virtual simulation of your products. How many of you are doing a product development using simulations here? Okay, only 3 hands I see. Okay. I think we'll see why it is so important for MSMEs, to do a simulation-driven product development. And we also talk about digital engineering in a very broader sense, not only just in terms of product development, starting from the conceptual phase to the in-product phase, where we are talking about ADAS, digital twins, and other things. Okay? So, just a brief intro of our company. CAD-FEM is basically a global company, which is our parent company is in Germany, and in India we started in 2007. So what we are majorly into is, we actually are one of the largest producers of simulation technologies in the world. Okay. Along with it, we also kind of have 40 years of experience in terms of rapid product development and also innovating for a lot of our customers. Especially we deal with a lot of MSMEs in both India as well as Germany, Southeast Asia, and all other countries. And also we deal with a lot of bigger customers, starting with like Bosch or let's say Grundfos and other companies too. Okay. And the major advantage what we have as a company, a group is because of a global presence, we could develop an expertise in different physics, because simulations, when you talk about it, or digital engineering, when you talk about it, it's no more one single engineering or one single physics for that sake. So we have a vast range of physics which we are dealing with, starting with the structures. We talk about CFD, we talk about electromagnetics part of it, both high frequency, low frequency. Like low frequency when I talk about like motors and all. When I talk about high frequency, I'm talking about PCB boards, radars, and then we are talking about optics, where you are talking about lidars, laser weapons or optics lenses and everything, right? And then we are talking about embedded systems and also the functional safety and cyber security of your products. That's becoming very much important nowadays, because of a lot of OEMs are asking to make sure that your product is, because you have a software and it should not be hacked, right? So the cyber security becomes very, very important for all your products when you're offering it to your customers, right? So all this comes into picture, and those all things we can simulate and test and virtually test them and get a much more insight into all of this. So about us in India, I think as I said, we started in 2007. Our parent company is in Hyderabad. It's hardly a few hundred meters from here. But we also have offices wide across India in 7 different locations: Bangalore, Chennai, Pune, Delhi, Coimbatore, and Ahmedabad. Okay. So we have a wide range of expertise. So we deal with, in India itself, we have around 300 plus customers, and majority of them are MSMEs. Okay, so for us, digital engineering is very, very important. So we start with the centric of customer, where customer wants to innovate, make their products more efficient, and also reduce the cost of their products, right? So when that is what they want to do, the first thing what they want to do is how to adopt the simulation. Okay, that's the first step. How can they use simulations to drive their innovation or drive their product? Second thing is to automate the simulation itself so that you can democratize it across the users, and you can make it much more user friendly, because doing simulation is one front, and making user friendly and because a lot of people who are talking about the skill gaps and all, right? So to overcome that, you can also automate it and actually make it much more button click solutions, where you can do your simulations, especially when you're talking about sectors like non-engineering, I mean to say non-traditional engineering sectors like pharma, where they are using simulations nowadays. They want to go in silico instead of in vivo and in vitro, right? So when you're talking about in silico,